everyone, this is Asiya. Today we are going to learn the law of indices. First, let's understand how to write an index. Now, index is the singular of indices, while indices is the plural. Now, let's learn how to write the index. Now, 2 to the power of 4. So, here the number 2 is the base. And the number above the base, which is 4, is called the power. Now, power has multiple names according to different books. So, it can be called power, exponent, and it can also be called as index. To begin this lesson, let's understand some of the important points. So the first point is that any law of indices is only applicable if the bases are the same. Now the second point is that A is same as A raised to 1. If you are not getting this point, let me say that if the base doesn't have a power, we can consider it as it has a power of 1. Now the third point. If the base has a power of 0, the result will always be 1. Now let's start with law number 1, the multiplication law. Now what is the multiplication law? This law states that when the bases are multiplied, the powers will always be added. Now let's write this law. So A raised to m into A raised to n is equal to A raised to m plus n. So here you can see that we are adding the powers to get the result. Now remember that the powers can be all numbers, negative numbers and fraction numbers. Now let's go through some examples to understand the multiplication law. So the first example, let's take a base called x. So x raised to 6 into x raised to 2 is equal to, now we have to add the powers, x raised to 6 plus 2. Now let's add the powers to get the final result. X raised to 8. So this is our result, x raised to 8. Now let's take another example of the negative power. For example, x raised to 9 into x raised to minus 3 is equal to, now we have to follow the same method, add the powers. So x raised to 9 plus minus 3. Now here we have to apply the integer rules. So the positive and negative will become negative. So as a result, we will rewrite this as x raised to 9 minus 3, which is equal to x raised to 6. This is our result for the negative powers. Now let's take another example of fractional numbers. So the third example, for example, we have x raised to 2 by 5 into x raised to, let's take 3 by 5. Now we have to follow the same method in fractional numbers too. So let's add these two fractions. X raised to 2 upon 5 plus 3 upon 5. Now there is the fraction fractional rule true. Now if the denominator is the same, we add the numerator. So we can add the numerator here, which is x raised to 2 plus 3 upon 5, because the denominator is the same, which is equal to x raised to 5 by 5. Now as you can see that 5 by 5 can be reduced into a whole. So we can directly write this as x. You don't need to write the 1, as you've already learned in the important points that you don't need to write 1 because the base alone can be considered as it has a power of 1. Now there is an important note that if there are multiple bases, we have to add the powers separately for each base. Now if you are getting confused, let's take an example for this note too. So for example, you have a base such as x. So x raised to 3 and y raised to 2. Now as you can see, we have two bases, x and y. Now how do we solve this? Okay. X raised to 4 and y raised to 2. Let's take 2 only. So which is equal to, now you can see that we have to take different variables such as x and x are the same in both of them. So let's take x here and let's separate it because we consider the same basis. Okay, so we're just taking x. Now let's see, the first thing has a power of 3 and the second number has a power of 4. Now let's add these powers of the x base. So x raised to 3 plus 4 and y, you also have y, so there are the same basis for y also. So the first one has a power of 2 and the second y has a power of 2 too. So now let's add these powers of y also. So y raised to 2 plus 2. So let's write the answers. X raised to 3 plus 4, which is equal to 7. And y raised to 2 plus 2, which is equal to 4. Now this is our final result. Now let's understand law 2, which is the division law. In this law, when the bases are divided, the powers will always be subtracted. Now let's write this law. So a raised to m divided by a raised to n is equal to a raised to m minus n. So here we have subtracted the powers to get the result as we are dividing the bases. Now an important point to remember here is that the powers here also can be all numbers, negative numbers and fractional numbers. Now let's take some examples for this one. So for example, we have a base called x again. So x raised to 4 divided by x raised to 6. Let's take x raised to 3 is equal to, now we have to subtract the powers as we are dividing the bases. X raised to 4 minus 3. So now let's subtract these powers. So x raised to 4 minus 3, which is 1. But as we learned that we don't need to write the 1 as the base itself is considered as it has a power of 1. So we can directly write this as x. Now let's take an example of negative powers. Example 2. Let's take x. X raised to 3 divided by x raised to minus 7. This is negative 7. So now we have to follow the same method, which is subtracting the powers. So x raised to 3 minus 7. Put this in bracket. Now as you can see here also we have to apply the integer rules. So both the negative signs, which are minus for this and this minus, will become positive. So we will rewrite the powers as x raised to 3 plus 7, which is equal to x raised to 10. So this is an example of the negative powers. Now let's take an example of the fractional powers. So for example, we have x raised to 4 upon 5 divided by x raised to, let's take 3 upon 5. So we have to follow the same method as we did for the positive and negative powers, which is subtracting the powers here also, which is equal to x raised to 4 minus 3 upon 5. So here our denominator is the same, so we don't need to change it anymore. So x raised to 4 minus 3 is 1. So our answer for this fractional is x raised to 1 by 5. Now there is a note here as well. So as we previously learnt in the multiplication law, that if there are multiple bases, you have to subtract the powers separately for each base. So it applies to this law as well, that you have to subtract the powers for each base where it has multiple bases. So now let's take an example for this one also. Okay. So the fourth example. So for example, you have x raised to 9, x raised to 2 and y raised to 4 divided by x raised to 3 and y. Y is alone here, so we have to consider it has a power of 1. So no need to write the 1. Okay, so here we have to first check that which bases are the same. So here x is the same in both the sides. On the left side, you have to take x raised to 2. So you just consider both the x's as 1. So x raised to the left hand side x has a power of 2 and the right hand side x has a power of 3. So we subtract both of them. 2 minus 3. Okay. And for the y part, the left hand side y has a power of 4 and the right hand side of y has a power of 1, which will be considered like this. So minus 1. Now we have to solve this. So x raised to 2 minus 3, which will be negative 1, because the larger number has a negative sign. So as the integral rule says that if the bigger number has the negative sign, so the result will also have the negative sign. So x raised to minus 1 and y raised to 4 minus 1, which is 3. Now let's understand law number 3, which is the multiple powers law. In this law, when the base has power of power, the powers will be multiplied. Now let's write this law. A has bracket, a raised to m, bracket close, n is equal to raised to m into n, and we can write this as a raised to mn. And now here there is also the rule in which we learned in all the laws, that is the powers of this law also can be all numbers, negative numbers and fractional numbers. Now let's go through some of the examples of this law. So for example, you have a base called x bracket, it has 3 bracket closed 2. And now you have to multiply the powers, which is x 3 into 2, which is going to be x to the power of 3 into 2, which is 6. So our final answer is going to be 6. Okay, so now the second example. Okay, now the second example we'll take is of the negative powers. So for example, you have in bracket x raised to minus 2 and outside bracket it's positive 5. Okay, so now you have to follow the same method of multiplying, but there will be applied some integer rules. So negative 2 into 5. Now here we have one negative sign. In the multiplication, when there is one negative sign, then the result then the product will be also negative. So x raised to negative 2 into 5, which is going to be negative 10. So our result is x raised to negative 10. The third example, let's take of the fractional power. So in bracket, let's take x raised to 2 upon 5, and the outside bracket let's take 6 upon 5. So we have to follow the same method of multiplying. So in the fractional rules, when you are multiplying the fractions, then you have to multiply numerator into numerator and denominator into denominator. So x raised to 2 upon 5 into 6 upon 5. So here let's multiply the numerator into numerator, which is 2 into 6. X raised to 2 into 6, which is going to be 12, upon 5 into 5, the denominator into denominator, which is going to be 25. So we cannot further simplify this fraction, so our result will be as it is, which is x raised to 12 by 25. Now there is also this rule which we learned in other laws, that is, when there are multiple bases, the powers will be multiplied separately for each base. Now let's take an example for this law too. Okay, so we have, for example, x raised to 3, y raised to 2, bracket, this is in bracket, and the outside bracket, let's take a number 5. Okay, so first you have to consider the variables here, which is x, and you have to multiply as the bracket is outside like that. So first let's multiply for the x. So x has its own power, which is 3. So we take 3 here, and it also has the whole bracket is the whole thing is being multiplied by 5. So you do into 5, as the whole thing is being multiplied by 5. Okay. So now y. Now y has its own power for 2. So let's write 2 here. And the whole bracket is being multiplied by 5. So it will also be multiplied by 5. Now let's find the result of this. So x raised to 3 into 5, which is going to be 15. And y is going to be 2 into 5, which is going to be 10. So this is our result for the question. Now let's understand the last law, which is the power zero law. This law states that when any base has a power of 0, it is always equal to 1. Now let's write this law. So a raised to 0 is equal to 1. Now let's take some examples for this law. So for example, x has a power of 0, then its answer will always be 1. And let's take a number. So if 12, this number is 12, so 12 has a power of 0, its answer will always be 1. Lastly, as we have learned many laws, let's recap of what we've learned today. So, 1. If the bases are multiplied, the powers will be added. Number 2. If bases are divided, the powers will be subtracted. Number 3. If the base has a power of power, the powers will be multiplied. Number 4. Any base with power of 0 is always 1. Number 5. Powers can be all numbers, negative numbers, and fractional powers. Now number 6. If there are multiple bases, you need to add or subtract or multiply powers separately. I hope you've learned this lesson in detail. Thank you.